In this lesson, we're going to look at the universal and the existential quantifiers. The universal quantifier is the statement for all, or every, and it's represented with this upside-down A symbol. It's used to make statements about all elements of a certain set. So, for example, if S is the set 1, 2, 3, 4, we could represent every element of S is less than 5 using predicate logic and quantifiers. So the predicate P of x would be x is less than 5. And the statement every element of S is less than 5 could be written for all x in S, P of x. So in this example, you're required to know a little bit of set theory. This symbol here is the element or membership symbol, just meaning elements of elements of S. And this for all means every element of S. So every element of S is P of x, or is less than 5. The other quantifier is the existential quantifier, which is there exists, or there is. And it's represented by this upside-down E symbol. So we can use this to make statements about an element of a set. We could say there exists an x such that x is less than 2, and this backwards symbol is such that. So it's always paired with the existential quantifier. And as I read this, you heard me saying this statement. So that's the English statement represented by this statement in symbols. There exists an x such that x is less than 2. So we could say S is the set of all cars, for example. And write the statement, there are purple cars with predicate logic. So to do that, we would need to define some kind of predicate. The predicate could be P of x is a purple car. And then to write the statement that there are purple cars, using some formal logic, we could say there exists an x in S such that P of x, which would be there exists an x in S, which is the set of all cars, meaning, okay, so this part right here says there is a car. That's what there exists an x in S. Then we have this backwards membership symbol, which is such that. And then P of x, which states x is a purple car. So there is a car such that, and then we could use it to refer to the x. It is purple. Doesn't sound very good when written exactly this way, but that's the way to write it in logic. And of course in English we would just say there are purple cars. So now we're able to make statements about things like there are such and such, or every element of such and such satisfies this, which we were not able to make with negation, or, and, exclusive or, implies, and if and only if. So you have one more tool now in your repertoire for making logical statements.